The measurement of the distances between celestial bodies and the process of determining their speed. Measuring distances between celestial objects and determining their velocities are crucial for understanding the universe and its workings. Throughout history, humans have developed various techniques to measure these quantities, ranging from simple triangulation to sophisticated astronomical instruments. One of the earliest methods of measuring celestial distances was triangulation. In this method, astronomers measure the angle between the line of sight to the object in two different locations on Earth. By using basic trigonometry, they can calculate the distance to the object. This method was used extensively by early astronomers, but it had limitations, as it only worked for relatively nearby objects. Later, astronomers developed more sophisticated techniques for measuring distances, such as the parallax method. This technique relies on measuring the apparent shift in the position of an object in the sky when viewed from two different locations on Earth. By measuring this shift, astronomers can determine the angle between the two lines of sight to the object and calculate the distance. This method was first successfully used to measure the distance to a nearby star in the 19th century. Another method for measuring distances is the spectroscopic method, which relies on the relationship between a star's spectral type, luminosity, and distance. By analyzing the light emitted by a star, astronomers can determine its spectral type and calculate its luminosity. By comparing the star's luminosity to its apparent brightness, they can estimate its distance. To determine the velocities of celestial objects, astronomers use a variety of techniques, such as Doppler spectroscopy. This method relies on the Doppler effect, which causes the spectral lines of an object to shift towards the red end of the spectrum if it is moving away from us, or towards the blue end if it is moving towards us. By analyzing these shifts in the spectral lines of stars and galaxies, astronomers can determine their velocities. In addition to these methods, astronomers also use a variety of sophisticated instruments, such as telescopes, interferometers, and radiotelescopes, to measure distances and velocities. These instruments allow astronomers to observe celestial objects in greater detail and with higher accuracy than ever before. In addition to the methods and instruments mentioned above, astronomers also use a technique called astrometry to measure the positions, distances, and motions of celestial objects. Astrometry involves measuring the precise positions of stars over time and using this data to calculate their distances and velocities. Astrometry is particularly useful for studying the motions of stars in our own galaxy, the Milky Way. By measuring the motions of nearby stars, astronomers can map out the structure and dynamics of the galaxy and even estimate the mass of the Milky Way. Another important technique for measuring distances in astronomy is the cosmic distance ladder. This technique involves using a series of progressively more distant and precise methods to measure distances to celestial objects. For example, astronomers can use parallax to measure the distances to nearby stars, and then use the brightness of certain stars called Cepheids to estimate the distances to more distant galaxies. By combining these methods, astronomers can estimate the distances to objects billions of light-years away. Finally, It's worth noting that measuring distances and velocities in astronomy is not just a technical exercise. These measurements are crucial for testing theories and models of the universe, and for answering fundamental questions about the nature of space, time, and matter. By continuing to refine these measurements, astronomers are helping to build a more complete and accurate picture of the cosmos.